Hello, good afternoon, good evening, everyone who all are joining in and who may join later in the session. This is your host, Himanshi Kaushik, and I hope that you all are doing good, fine, safe, sound, and happy at wherever you're taking this session from. So today we have joined here to witness a session on machine learning, basically, and impact of data science on the current industry, as you can see. And we actually, just want to know that what is the power of machine learning and how it can actually transform data into actionable insight. And for this, we have our expert here. So I shall introduce you to our expert. We have Mr. Harshvardhan Palawat here with us, who is a machine learning engineer with over 4 years of experience in building data intensive machine learning applications and overcoming complex architectural and scalability issues in diverse industries. And he is proficient in predictive modeling, data processing, data mining algorithms, and he also is well versed in scripting languages, including Python. So I think, we would be learning a lot through this session, and I welcome you, sir, in the webinar today. And I think before I request you to take over the screen, I want all the participants to know that now you can post your queries in the chat box or Q&A box so that, we just don't miss them. And at the end of the session, we also allow you to talk to our expert. You just have to raise your hand. And with this, sir, Ashwadan, sir, I request you to please take over the screen. Looking forward for an amazing session, sir.
Hi, everybody. Thank you so much, Himanshi, for such a warm welcome. And I'm really excited to be here. It's always a pleasure to be among students. Uh, okay, so just to make sure that chat section is working fine, can you just give me a hi, guys? I hope everybody is doing good and you guys are excited about uh, the introductory session that basically opens the doors to a whole new domain, I would say. And we'll be discovering a lot about the potential of data, data science, and machine learning in this session together. Wherever and whenever you feel you have some issues or doubts, feel free to write in the chat section. And hello, everyone. Yeah, so let us start. So as you can see on my screen, I hope my screen is visible. I hope you're not facing any issues with my video, with my audio, or my presented screen. Okay, great. Thank you for the quick confirmation. Now, this is the brief agenda of today's session. We'll first understand what data science basically is, and we'll understand why should one learn it and why this is the right time. This is, in fact, the perfect time to learn data science. Then we'll go on to the types of data that we use in industry, then the skills that you would require to get into the domain of data science or machine learning, the jobs that you can apply, and then we'll just understand a few things about the upgrade program, its highlights, and lastly, we'll have this question answer session. So data science, machine learning, and AI. I am damn sure that you might have heard about these buzzing words, right? And you must be really curious about what each of these terms means and how these are different. Okay, what is the similarities, what is the differences, and we'll try to understand everything in this session. So if I talk about data science, the basic definition says it is the science of exploring data to get actionable and useful insights for businesses. Please excuse me my uh, bad handwriting, but I guess you guys are able to understand what I have written here. Data science is nothing but the science of exploring the data, analyzing the data. And why would we want to do that? Because we want to get out actionable and useful insights for the businesses. Now, actionable and useful. These are the key terms here. I want you guys to focus on these terms. Because given that you have a data set, you can explore it and you can take out a lot of information, but not everything is useful to a business. Plus, given some insight is useful, it always is not actionable. You cannot, put some sort of action based on that insight. And that is why businesses would not get profit out of such insights. I hope you understand what I mean here. In order to put everything into perspective, let me take a really simple example. I guess everybody would be able to relate to this. You must have seen these large uh, retail chains like Big Bazaar or Decathlon or something like that. Let us say that they have a lot of data on their customers, where they have the name of their customer, the item the customer purchased, the date when this purchase was made, the amount of the purchase, and such information about every transaction that has been taken place in the past. Now, one insight can be, as a data scientist or a machine learning engineer, I can basically analyze the data to find out that 20% of my customer's name starts with RA. Is this information from my data? Absolutely yes. But is this useful for my business? I don't think so. I don't, I don't, get a direct use of this information to generate more profit. Therefore, I wanted you to focus on these two keywords. Let me write another insight that you might get from this data. And that might be 27% of my customers are in an age range 16 to 24. This is another insight. And this looks like useful, right? I know my customers. After getting this information, I know my customers well. But still, I would have to generate a strategy through which I can put this insight into action. And what is the action associated? Without the associated action, it is of no use to me. What could be an action associated with this? Maybe I would try to launch such product ranges which are of the interest of this customer base. Why would I do that? Because I know that majority, more than 1/4 of my customers belong in this range. So this is how we utilize the power of data science to extract information. Let us just go step by step here. Extract information. Do I just want to extract information? No, that is not the goal. The information should be useful, because you know that this was also information, but this was not at all useful for my business. So not only I just want to extract information, I want to extract useful information. This second stage is it should be useful. And the third and the most important stage is the information should be presented in such a way that it could be easily converted into actionable items. The stakeholders should be able to attach those insights with some actionable items and keeping in mind that once you have just, completed those actions, your business should go towards growth. It should generate more profit. That is the end goal of data science. So that is all about the definition of data science. Now, data science is not just one domain. It is a mixture of multiple disciplines. For example, to be a good data scientist, you need to be good at marketing. You need to have the domain knowledge of the field that you are working in. For example, if you're working in medical domain, you must have some sort of knowledge so that you are able to relate yourself with the data. For example, if you are working in retail domain, the example that I just gave you, you should have some knowledge of that domain. So first of all, you should be a subject matter expert. Not let us not just use the word expert here, but you should be aware of how the domain works. At the same time, you are required to have the knowledge of statistics, mathematics, and traditional research methodology. Just a minute. Soumya has a question. Is data science in our first year? And I don't think I'm the person to answer this. But even if data science is in your first year, you're good to go. I don't think you require any sort of prior experience or anything of that sort, which would hinder your learning curve if it is introduced in your first year. Cool. So you'd require some sort of domain knowledge. At the same time, you would require the knowledge of core statistics, probability, mathematics, and these kind of fields. At the same time, you would require the knowledge of software engineering, data engineering, and obviously at the center lies this field, machine learning. Okay. You should be able to understand your customer well, because obviously if you are not understanding the data, you would not be able to ask the right questions, which is extremely important. Taking the same example of the data set we have seen, the first question that we have answered, how many customers' name starts with RA? It is not a good question, because the answer to that question would not give me any profit. Okay, but the second question that we have seen, what is the distribution of my customer base in the age range 16 to 24? That was a valid and a good question. And I could only ask good questions if I understand my customers well. This session is supposed to go for 1 hour approximately. Then again, you should know how to generate insights which could be converted into actions further. Because without actionable items, insights are just information. And you would not get benefited of it, right? Then if we come to the side of data engineering, you should understand what sort of constraints you should put on your data. For example, what are constraints? I hope you know the basic meaning of constraints. What are data constraints? For example, you have this database where you also have some private information like email ID of the customer or phone number of the customer. And often these retail chains, collect this data. But you would not want this crucial information or private and personal information to be seen by a lot of people. Maybe a lot of people are working on, the data side team, right? But you would not give access of this information to everyone. Therefore, you would put some sort of constraints. And you would apply some sort of data governance. Data governance in simple words means who can see what in your data. You basically define that in data governance. Obviously, you should get right data. For example, if you want to see the distribution of your customer base on their ages, you definitely should have a column for age or date of birth. If you do not have that information, you cannot even start with this analysis. Data preparation. Let me give you a really simple example here. For example, you want to get age of the customer. but the column or the information that you have regarding the customer is date of birth. You'll have to do some sort of operation, and you'll have to prepare your data in such a way that from this date of birth, you're able to extract the age, which is not rocket science, but still you need to do that, right? You should have a good amount of knowledge on structured query language. Reason being, a lot of time these data sets and tables are stored in databases, and you need to first query the data, get the data, store it into a data frame, and then start working on it. So you should know how to do this with help of structured query languages. You should have an intuition of the matrix that matters for your business. Again, a really simple example. Let us say you are a machine learning engineer at YouTube. Now, a metric is a number which defines the growth of a business. Okay. What number would you choose for YouTube? I'll give you two options. The first option is, let us say the number of videos watched. The number of videos watched daily. And the second option is the duration of videos watched. What do you think would be the most effective metric that could give us an idea of growth of YouTube? One or two? Feel free to write your answers in the chat section. Azad says two. What about the rest? Is the question clear? Okay, let us assume you are a machine learning engineer at YouTube and you need to create a metric for YouTube. What do you mean by metric? Metric is a number that defines the growth of a business. Okay. Now, you can either choose to define this metric as the number of videos watched daily. For example, when YouTube was started, maybe only 20-25 videos were being watched on daily basis. But today, I guess billions of videos are being watched on daily basis. So what do you think? The number of videos is the most effective metric, or the duration of videos? For example, when YouTube started, maybe on an average, people were watching it 15 minutes a day. But today, you know that a lot of people are watching YouTube for hours and hours. Some says one, some says two. And now this is where it is important that you understand the business and understand the customers. Because I'll tell you the problem with metric number one. For example, you are a viewer at YouTube, and what you do is you just click on video number one. You do not like the video, you close it. You jump to video number two, you do the same. Jump to video number three, video number four. You jump to 10 videos, but the total time you spent on platform is less than 5 minutes. Technically, you have started a lot of videos. You have not even watched them completely, but you have started a lot of videos. Therefore, the first number is 10. But what is the second number? It is less than 5 minutes. So the first metric would lead you into thinking that YouTube is doing really great, or my platform is doing really great. But is it really so? I'm afraid no. Because technically the users are not liking the videos, and that is why they are not spending a lot of time. Therefore, the effective matrix would be the duration they spend on your platform rather than the number of videos they open. I hope this is clear now. So you should be able to define the metric that matters, because obviously this is the metric the business runs before. Okay. The entire goal of any business is to improve this metric. Now, if you keep on trying to improve the number of videos that users click, you might not get them to spend a lot of time on the platform. Therefore, you should focus on something that really matters. And in order to do so, you first have to identify what really matters for your business. You should be able to translate your results and findings for non-technical audience as well. Okay. Because what happens is, as a data scientist or machine learning engineer, you'd be presenting these insights to your stakeholders. And who are the stakeholders? Typically, these are CEO, CXO, VP type of people. And mostly they come from non-technical background. If you talk in technical terms to these people, you would lose them. They would not understand, and you would not be able to convert your insights into actionable items. So it is crucial that you have this knack for converting technical stuff into a non-technical storyline. You should be a really good presenter to be a successful data scientist. Exactly, Niaz. Duration matters more than number of videos watched. Similarly, as we were talking about the distribution of my customers in the age range 16 to 24, in the previous example, it is crucial that you understand these statistical concepts like distribution, PDF, CDF, mean, median. You should understand what standard deviation is. What is the concept of range? What is the concept of central tendency? What is the concept of dispersion and all these stuff? That is only when you would be able to basically interpret your results well, read your results well. So at the same time, you should have the knowledge of statistical packages, advanced math, how to do modeling, and scripting languages like Python, because at the end of the day, you are building software, you're building products, and you need to be proficient in one of the programming languages. And for machine learning, data science, and artificial intelligence applications, Python is the best language today. Okay, there's no doubt on that. So this is just a basic introduction of the term data science. And in one line, just to summarize everything, it is all about studying the data to explore useful insights and turn them into actionable items so that your business can grow. Okay. And actionable and useful are the key terms here. And useful and actionable depends on the business that you are working for. These terms might have different meaning in context of different businesses. And in order to become a good data scientist, you should have a good amount of knowledge of various disciplines, as shown in this slide. Now let us move on to our second buzzword, which is machine learning. Machine learning is nothing but the science of creating such computer programs that basically learn from experience E with respect to some task T and measured on some measure P in such a way that its performance on task T improves with experience E if we measure by P. In simpler words, I want my machines to have human-like thinking capability. I want them to learn from some experience. And in most of the cases, this experience comes from some data. I want the machine to learn automatically from some experience or previous data in order to get better. Get better at what? Better at a particular task. T. Now, how would I decide that my machine is getting better at that task? I would basically define a measure of its performance. P. And now if we go back to the definition, it makes more sense. Machine learning is a computer program which basically learns from experience or previous data with respect to some task and performance measure P if its performance at task T as measured by P improves with experience. That means if you provide it with more data, it becomes better at doing the same task without explicitly being programmed for it. There are two sorts of computer programs. Machine learning itself is nothing but a computer program. But we have rule-based computer programs, and then we have machine learning programs. And it is crucial to understand the difference between these two. Rule-based programs are simple functions that you write and you define some specific set of rules. And these kind of programs can only work under one of these rules with one of these conditions. You can basically understand these as if-else conditions. You'll have to define all the conditions. If some condition is not defined, your algorithm will not perform. On the other hand, machine learning program does not require explicit instructions or rules from the user. It learns these rules. How does the machine learning program learns these rules? Using this experience E. Where does this experience comes from? The previous data. And obviously they can only learn to get better at one particular task. This is the concept of machine learning. Any doubts in this definition? See, hacking and data, this is a good question. Somebody asked how hacking and data science are related. Obviously, hacking and data science does not have any direct correlation, but you're working with a lot of data. And when you're working with data, obviously the data has come from your customers. And once you have a lot of data from your customers, it becomes your job to kind of ensure the security and integrity of the data. You might have heard that in history, a lot of firms have gone down just because of the fact that the data was breached and there were a lot of security concerns. Therefore, there's an indirect correlation between the hacking world and the data science world, where in order to work on a lot of data, you'll have to first ensure the security of the data. And you can only ensure the security of the data if you have cyber security experts, or if you yourself know something about cyber security. That is how the world of hacking and data science are related. Okay, somebody asks me to repeat this. The simple definition of machine learning is that I want to design such machines which can learn to perform tasks on their own without being explicitly programmed. And obviously, we'll see a lot of use cases. Right now, I'm just giving you the basic definition of data science and machine learning. This is not the end of this lecture. I have a lot of examples where you would be able to relate these definitions with the real world applications and understand better. So just bear with me for a couple of minutes. Okay. But basically, I want to create such systems. Machine learning is all about creating such systems which can perform some tasks without being explicitly instructed. Okay. Now, how does data science, machine learning, and artificial correlate with each other? This Venn diagram would give you a fair idea of how these terms are interrelated. So artificial intelligence is a really big umbrella which includes the domain of machine learning, and then machine learning has some sort of intersection with data science. Okay, artificial intelligence is a generic term where we also talk about the concepts of data science, the applications of machine learning. At the same time, if you just talk about the concept of data science, a lot of part is common between machine learning, artificial intelligence, and data science, but a lot of part is not. For example, if you remember in the first slide, I told you that data science is a combination of a lot of disciplines. It also involves data analysis, exploratory data analysis, data visualization, feature engineering, which is also a part of the world of machine learning. But there are a lot of other stuff which involves maths, statistics, and all of these terminologies, which do not correlate with machine learning and artificial intelligence. Why should we bother about this domain or field known as data science? Why is data science becoming so popular in today's world? Any guesses? Anybody wants to answer that? Why, in your opinion, is data science becoming so popular? Exactly, due to a lot of data. You'd be surprised to know that today we have approximately 160 zettabytes of data that we have produced. And the data being produced today is exponentially increasing in terms of the WhatsApp messages that you are sending, in terms of your Instagram posts, in terms of reels, YouTube videos, in terms of wherever and whenever you click on a website, you're generating data. So the quantity of data is huge and enormous. And obviously, we would want professionals who can deal with this data, who can basically extract the most useful information from this data so that our businesses can flourish and grow based on these insights. And just to put this in perspective, 1 zettabyte means 10 to the power 9 terabytes, which means 1 crore terabytes. This is the volume of the data that we are producing. And this data is just increasing. It is not decreasing. And because this data is increasing and the interest in getting insights from this data is increasing, so does the jobs. We have a huge gap in supply and demand. Obviously, to tackle this volume of data, you'd require a lot of professionals, a lot of skilled candidates. But we have a scarcity of that. And that is why the jobs are increasing. And I'm just saying this from my experience today, that data science and machine learning is one of those domains which takes the maximum number of time on an average to fill a vacancy. If you talk about other IT roles, it would take somewhere around 2 to 3 months to fill a vacancy. On the other hand, it takes 4 to 5 months easily to fill a data scientist role because we have a huge gap in supply and demand. The data is just increasing. There's no control to that. At the same time, the supply demand is not, balanced. That is why this is the best time to get into the domain of data science. Then let us talk about a little bit on the type of data that we use in industry. So the easiest form of data that we use for data science and machine learning is tabular data. The kind of data we talked about in our example so far, where the data is stored in terms of rows and columns. For example, Excel sheet, for example, your databases. You'll get to know more about databases in some of your courses. I'm sure of that. Then other kind of data is image data. And you know that we are generating a lot of new images and we are putting it out on social media. That is just a habit now. Image data is nothing but a 3-layer RGB matrix. I hope everybody knows about the concept of a matrix. I'm sure everybody has studied matrix in their high school. So image is nothing but a matrix in 3 layers. I have one matrix. Behind that, I have another matrix. And behind that, I have another matrix. Why only 3 matrix? Because mathematically, images are stored as 3 color channels: red, green, and blue. And you'll definitely read more and learn more about this in your future courses. Then videos. Videos are nothing but different images, right? If multiple images are placed and I just play those images in form of frames, I'll get a video. After that, I have text data, and everybody is aware of the text data. The LinkedIn post you put, the Facebook post, the Twitter post, any sort of comments, any sort of messages that you share with each other is textual data, emails, everything. And then towards the end, we have audio data, which is nothing but a sequence of voice frequencies, human speech, music, different sounds. For example, we have a lot of devices that could work with human voices. For example, Google Assistant and Siri and whatnot. And if you have used these, they basically take permission to record your voice so that they can train your voice, they can train their algorithm and their applications on your voice and make it even better. So this is where the definition comes into picture. A program which learns from experience. Here, the experience is nothing but your voice. And it is trying to get better at a task T. What is a task T? Understanding what you are trying to say. And the performance will be measured using some measure P. Then we have a few sort of uh, algorithms. We can broadly divide our algorithms into 3 categories. Before this division, I want to tell you that I can divide my machine learning algorithms into supervised and unsupervised algorithms. Supervised algorithms can be further divided into classification and regression. And unsupervised learning can be divided into recommendation, clustering, etc. What do you mean by classification? When you're trying to predict the class of something, for example, does a patient have cancer? Yes or no? So you're trying to predict a class, a category corresponding to some entity. Here, the entity is your patient. Obviously, you would require some sort of input information, and this input information is known as attributes or features. Based on the values of these features, you basically try to predict either yes or no corresponding to that entity. Similarly, in regression, you want to predict a real value. For example, price of a house, maybe price of a car in second-hand market. And based on attributes like the mileage of the car, the make year of the car, uh, the engine capacity of the car, the brand of the car, and other such attributes, you would try to predict the value that it has currently in the second-hand market. Okay. Then recommendation is a generic concept where if you have a lot of customers, let's say you have a lot of customers, customer one purchases item one. You try to find customers who are really similar to customer one, and you would recommend this item to all those customers so that your sales and profits are maximized. The basic principle is first you would try to group customers into similar items based on some attributes like maybe age, maybe the location from where they are coming, maybe their purchasing power, maybe the devices that they are using, and something like that. Once you know what customers are similar to each other, you'll basically recommend the item purchased by one of the customer to all the other similar customers, because these customers have similar behavior, and that is why they have maximum likelihood of buying the same product that this customer has bought. Then if you talk about image and video data, there are applications of classification. What is classification? You could create a machine learning algorithm to classify whether the image has a cat or a dog, which is a really simplistic example. Then you have something known as object detection. You can create a machine learning algorithm which would detect whether the person in front of the camera has wore a mask or not, which was extensively used in COVID times. A lot of these systems were deployed in offices, in malls, in schools, colleges, where you would not have to deploy a physical person at the entry gate. You just need to install a camera. The camera would capture a feed, a real live feed of the person standing next to it, and it could detect whether a particular object is there or not. And in our case, the particular object that we are talking about is a mask. Then face recognition. I hope I do not have to mention the real world use cases of facial recognition. For once, for the simplistic uses, it is used for unlocking your phones, and it is also used in complex security systems. You must have seen these kind of facial recognition systems in Hollywood movies and even Bollywood movies. Then pose estimation. Pose estimation is a really good use case if you want to create an application for a personal AI trainer. Typically, a gym trainer cannot, kind of focus on all the members that come to gym at the same time. But with help of a camera, you can create a pose estimation algorithm, which would automatically uh, give them a warning if their pose is not correct for some particular exercise. And let me again just put the definition of machine learning in perspective in context of this problem. Obviously, at the beginning, the machine does not know anything. Now, what you would do is you would give it with a lot of correct poses for various exercise. Let's say corresponding to every exercise, you give it 100 different poses which are correct and 100 different poses which are incorrect. Now the machine gets trained on this data. And by training, I mean that the machine is learning to identify whether the pose is correct or not based on this experience, based on this previous data that it has seen. And it wants to get better and better at this. Then the next is text data. And text data has the most number of applications that you see today. For example, you must have seen that on e-commerce websites like Amazon and Flipkart, a lot of users give their reviews corresponding to a product. Now, analyzing the sentiment of the user from these reviews is one of the applications of text data in machine learning. Analyzing, a lot of posts that you put on social media, whether it contains some content of self-harm or hate or anger, is another application, which helps platforms basically remove those applications, those feeds or content which might not be appropriate for other users. Obviously, they do not have to employ a manual team to go through all the posts that are being put on social media. Imagine if they have to manually go through all the posts and approve all the posts before showing them to other users. How long would it take? On the other hand, we have a machine learning system which goes through all these texts that are being put by the users on daily basis, and they decide whether this is appropriate or inappropriate by analyzing the contents of your text. Then we have a really useful application known as named entity recognition, where you basically identify the entities, the grammatical entities in a sentence. For example, if you write Delhi is the capital of India, Delhi is a noun. Then topic extraction. For example, you have a long text and you just want to know what the text is all about. Does this belong to sports? Does this belong to Bollywood entertainment? Does this belong to politics or something like that? There are a lot of applications of this sort of topic extraction. To name a few, uh, if you'll open any news website today, they'll ask you for your preferences and they'll only try to show the news that belongs to your preference. How do they identify this? How do they basically map a news article with your preference? And it starts with the concept of topic extraction. Given any news article, they first extract the topics that are mentioned in that news, and they simply check whether you're interested in those topics or not. If you are, you are notified. Otherwise, it is ignored. And we have a ton of other applications. Going forward, I hope everybody is using the application of audio data and machine learning in their day-to-day life. YouTube voice search, uh, Google search, Google voice search, Google Assistant, Siri, your Alexa, everything is the product of the combination of audio data and machine learning, where these systems have learned to recognize your speech. They can also convert your speech to text. They can also, you must have seen these security systems in movies which are voice activated, which only opens to some particular voice. Again, at the very basics of all these applications lie machine learning and audio data. You can also convert text to speech. You can write something and you can convert it into a voiceover. These are some of the jobs that you can apply once you basically understand the concepts of machine learning and data science. You can be a business analyst. You can be a data analyst. You can be a data engineer. You can be a machine learning engineer. You can be a research engineer. You can be a data visualization engineer, or you could be a data scientist. If we talk about the remuneration of freshers in the market, to talk about the least, it starts with 6 LPA. This is the least in my experience. But if you are a decent skilled data scientist, you can easily get anywhere between 9 to 15 LPA. And this is the decent range. This is the achievable range. And given you are excellent, obviously there's no limit to that. But this is the range which I have seen a lot of freshers bagging into the market. Given you are hardworking, you have the correct amount of skills, you know basics, you know algorithms, you can easily achieve this. And then this is a sample job advertisement which has been taken from LinkedIn. But in order to understand more about the skills that are required for various job roles, I would suggest you yourself go to LinkedIn, just search for that particular job role, go through a lot of job applications, and you'll automatically understand what is the set of key skills that you need to acquire to be something. For example, if you want to become a data scientist, you can go on LinkedIn, search for data scientist, and go through a lot of job advertisements, a lot of job descriptions, and you'll automatically understand what sort of skills are required to be a good data scientist. With that, my slides are over, and you guys can ask any questions if you have.
Yeah, I think so. We've got a question from Niaz. Says, what is the job data scientist? Okay, what are those jobs that data scientists do in the companies? Maybe you could just brief a little role about what do they do?
Typically, a data scientist is tasked with data management, first of all. What do we mean by managing the data? Obviously, you're generating a lot of data. How would you store that data? That is one. Once you have managed the data, the next task is pre-processing. What do we mean by pre-processing? Converting the data in such a format where you can run some sort of analysis on those. And then the next task is analysis. And the aim of this analysis is to gain insights which are useful and can be converted into actionable items for your business. So these are the major responsibilities of a data scientist.
Right. Thank you, sir. And so this one question, for example, if somebody has crossed that age, right, they've done like different course. So would they be able to learn the data science? And if they do, what do they need to do? I mean, for example, let's take an example. Somebody is at the age of 30 and wants to come in this field particularly. So what would be the pathway for that person?
First of all, because I have already talked about a huge supply demand gap in the market of data, there's no bar on age. There's no bar even on the degree and academic experience of the candidate. If you have relevant skills, you are always welcomed in this industry. Now, talking about the relevant skills, obviously, you should know SQL, you should know Python, you should know, and I'll just don't be confused there. I'll just use a few uh, names that you might never have heard of, but you need to know about the library known as Pandas, NumPy, and Seaborn, which is a visualization library, Matplotlib, which is again visualization library. You need to know a great deal about scikit-learn, which is the most famous library used for building machine learning applications. Then if you talk about deep learning applications, you need to have a good amount of knowledge of either TensorFlow or PyTorch. And at the basic of all these names that I have taken, you should know basic statistics, basic probability, basic linear algebra. If you kind of manage to get a good amount of exposure and experience in all these subjects, you're good to go. Does not matter what is your age, does not matter where you are coming from or anything.
Right. So thank you. And so a similar question has come from Krishnendu as well. What are those topics of advanced mathematics should one go through in order to take data science?
Okay, so the most advanced topic of mathematics that you need to know about is differentiation. If you can differentiate, you are done. There's nothing to go beyond that.
Okay. Okay. Thank you, sir. Um, Okay, so this question from Bhanu Pratap, and it says, sir, as you know that AI has been growing so fast, so what do you think the future of data science and scientists are?
I have been getting this question a lot lately because a lot of folks are kind of distressed about the latest advancements like chat gpt and all, and there's a lot of debate going around whether these technologies would eat up the roles that are present in the market. And you know the correct answer to this question is that as the systems increase, as the technology increase, you would even produce more roles to maintain that technology, first of all.
Right,
Secondly, an artificial intelligence system can never replace a human being, because if you talk from a business perspective, it is not just writing code. I'll give you a really simple example. Today, chat gpt can write code given someone provides it with a prompt, and that prompt should be the correct prompt. Now,
right,
who would write that correct prompt? As an engineer, I'll first understand the requirement of my client, and I'll convert that requirement into the correct prompt. So that gap of human interference can never be filled in the industry.
right,
So, and there's a really uh, famous what should I call it? It is known as Gartner cycle, which basically predicts the future of a lot of domains. And a lot of times they have predicted that the future is flourishing for at least 10 to 15 years in data domains. After that, we do not know. But till next 10 to 15 years, the potential is huge. The field is never stopping field, at least for next 10 to 15 years.
definitely, sir. And I think after entering into data science, you need to learn, of course, new things every day. You need to come out of your comfort zone, and hence can equip with the new technologies if they come in. And I think so. We're done with the questions here. And with this, I would like to thank you for joining in, sir, here and giving this presentation, sharing your knowledge, your experience with all the participants with me. Thank you so much, sir. And with this, I would want to take your permission to wrap this webinar. Shall I?
Sure. And just thank you for having me. I really enjoyed this discussion, and I hope you also have enjoyed.
Same, sir. I mean, it is like a mentor when telling things. It is again, as a student, I was learning, and I might, who knows, I might join data scientist, of course. So thank
You
you so
should. Everybody should.
much. Okay. And at last, I would just, okay, our participants are already thanking you, sir. And with this, I take your leave, participants. It was so great to have you here. All the questions are really appreciated. So meet you soon in the next webinar. Until then, stay safe, stay healthy, and thank you so much for joining in.